In this lesson, we're going to be talking about ARP, or the Address Resolution Protocol, and how you would make use of it and how it actually is used. So the first thing I want to do is show you what's called an ARP table. So every computer system carries what is called an ARP table. The reason it's called an ARP table is because it matches a layer 2 or physical address or MAC address to an IP address, and that's what ARP is. ARP is the Address Resolution Protocol, and what it resolves is an IP address to a MAC address or a physical address. And the MAC or physical addresses are interchangeable because they mean the same thing. The reason it's called a physical address is because it is physically on a network interface, which is, of course, a physical device. So it's sometimes called a physical address, it's sometimes called a MAC address for media access control. So I might use MAC address, I might use physical address to make a particular point, but it means the same thing. So you can see here there are IP addresses and there are MAC addresses that are listed in this ARP table, and I've done ARP-A, meaning show me all of your ARP entries. And while I'm doing this on a Linux system, it will work on any system pretty much that has the TCP/IP suite of protocols installed, because it's an important utility to have in order to help diagnose any issues with your network problems. So this is how you would display an ARP table, and as I said, ARP is just a mapping from IP address to MAC address. So let me show you how the protocol actually works. I'm going to do a little filter here just so that all we're seeing is ARP. And you can see on the info column here in Wireshark, it says who has 192.168.106, tell 192.168.1.1, and that's really what an ARP request looks like. What an ARP request is a message going out to the wire saying, hey, who has this IP address? I need to know the MAC address that goes along with it so that I can throw it out and get it to the right place. So ARP is really a local area network protocol, because once you get to the local area network, you're not communicating with IP addresses anymore. You are communicating with MAC addresses. So a system is only going to look at messages that have a MAC address that it has some control over. So either it's a broadcast MAC address or it's a unicast address that is directed to that particular system. So in order to get messages to the correct system on a local area network, you need to use the correct MAC address. So you send out a request. Who has a particular address? So here's an exchange here that we can take a look at. Who has 192.168.1.18? And I'm going to pop open the Address Resolution Protocol section here in Wireshark so we can take a closer look at it. And you can see it's a hardware type Ethernet, a protocol type IP. I've got an opcode of request. So the operation code is a request. I've got the sender's MAC address, which is how we know where to send it back to. And you'll notice the target MAC address is empty, and that's because we don't know it yet. So when the system who actually has that IP address or is responding on its behalf sends a message back, and we can show this one here, you'll see the target MAC address is filled in with the original requester, and the sender MAC address is filled in with the correct MAC address of that particular IP address. So you'll see sender MAC address happens to be an Apple device. Wireshark does a good job of actually decoding the MAC addresses so that it's got the vendor ID. So a MAC address is actually broken into two sections. The first three hex numbers there, 34, 15, 9E, are for the vendor. So the first half of a MAC address belongs to the vendor. That's the vendor ID. The second half is the device ID for that particular vendor. So Wireshark, as I said, will actually map the vendor ID to the vendor name. So I've got Apple and I've got Netgear here. So you can see the request in this packet here and the response in this packet here. So that's actually how ARP works. You send out a request looking for a MAC address based on an IP address, and you get a response with the correct MAC address. Sometimes you may need to go from MAC address to IP address, and you would do that using the Reverse Address Resolution Protocol, or RARP. So let me show you something here where you would make use of ARP. So let's say you're sending a message that is an ARP response, but there was no request to go with it. If you were running the system that received that request, what would you do with it? Well, you might discard it, but one of the easiest things to do is just log the information. That way you don't have to ask for it later on. You've just got a record of it. So if you happen to see a message with what's called a gratuitous ARP, or an ARP response that hasn't been requested, if you see one of those going around, you may just consider keeping track of it so that you know later on and you don't have to ask. It saves time and it saves network bandwidth. Here's a utility here that actually takes advantage of that. This is called EtterCap. EtterCap has the ability to do a lot of gratuitous ARPs and do what we call ARP poisoning, or a man-in-the-middle attack. So the first thing here I'm going to do is unified sniffing. And I'm going to get a host list. And I don't actually have any hosts that it's aware of yet, so I'm going to scan for hosts. And let me bring up the host list again. I am going to add a bunch of hosts to one target, and then I'm going to add another bunch of hosts to another target. So you create two targets, and then you set up your ARP poisoning. And I want to do that. I want to sniff remote connections. And this is my man-in-the-middle attack. It's ARP poisoning. I'm going to send out a whole lot of ARP responses here. And you can see there's a whole chunk of is-at messages that are going by. So 25, 33, 25, these are all at the same MAC address. That's what's going on here. I've got a whole bunch of gratuitous ARP messages that are being sent out onto the network saying, hey, this IP address belongs at the MAC address that actually lives on my particular system. And so messages that would normally be directed to that IP address would then come to me. Now, there's a bit of a challenge there because you need for the system that you are on to be able to forward packets, because you've got to get the messages back out onto the wire with the correct MAC address. Otherwise, nobody gets their messages. And so you start to think that something is a little bit screwy because suddenly there's no communication. And that's a big flag indicating that something is wrong on the network, and somebody's going to go start looking for what's wrong on the network, and they're going to see that, hey, guess what? Somebody's doing a whole bunch of gratuitous ARPs. They're going to track the MAC address back, and they're going to find your system there. So I'm going to shut down the man-in-the-middle attack here. And you can see that in addition to ARP poisoning, EtterCap has the ability to do other types of attacks as well, including ICMP redirect, port stealing, and DHCP spoofing. So EtterCap is a pretty good utility for sitting in the middle of conversations and seeing what goes on. And this is why I'll mention from time to time that switches are not effective tools to prevent people from hearing conversations that don't belong to them or that they're not normally a part of. Primarily because EtterCap just makes it so easy to do this ARP poisoning, in which case you're entirely bypassing the switch because people are addressing packets to you. So that's the address resolution protocol and some different ways of making use of it.